Greetings and welcome. This is an introductory video on chapter 20. I request you not to skip this video because I do not want you to mechanically solve the problems by multiplying something with something to get the result. But I want you to understand the core concept of this chapter, and the theme of this chapter is mensuration. So mensuration deals with 2D and 3D shapes and their measurements. Measurements of length, perimeter, area, volume, surface area, etc. The chapter name is Area of a Trapezium and a Polygon, and we will learn the length, perimeter and area of 2D shape. So you are already familiar with 2D shapes like a triangle, a rectangle, parallelogram, trapezium, circles, etc. In my previous videos, I have explained that a closed curve has a definite region enclosed by the boundary of the curve, and the interior region has an area. So what is an area? Area is the amount of space occupied by a closed curve. Now first let us understand what is perimeter. So at first let us recap from your previous knowledge of geometry. Perimeter is the distance around the edges of a closed curve or the boundary. What shape is this? This is a quadrilateral. If you start measuring from point A, you have to go around the edges or boundary of this figure and you end up at the starting point itself. So this total length of the boundary is the perimeter of the quadrilateral, and which is equal to length AB plus length BC plus CD plus DA. For a circle, if you start at point C of the circumference of the circle, you have to go around the circumference of the circle, and here the circumference is the boundary of this shape. So this is the perimeter of the circle. Now let us understand the idea of square units of area from this rectangle. The concept of area and its unit comes from a unit square. The area of the space occupied by this small square is the length multiplied by width, or side multiplied by side. But it is only true for a square or a rectangle because the sides are perpendicular to each other. These distances of sides are actually the perpendicular distances to each other. The amount of space may be equal to the area of any shape. It may be a triangle or circle or anything. The concept is the area of a unit square. So one square unit indicates the area occupied by a square shape of unit length of sides. So here the length is 1 unit and width is also 1 unit. The area of this small square is 1 square unit, and same area may also be occupied by a triangle or a circle or any shape. Now if I add 5 more unit squares with this one, then you get 6 unit squares. So area of these 6 squares is equal to 6 square units, and you can add another 6 squares. Area is now the 12 square units, and if you add another 6, you get 18 squares. So the total area is equal to area of 18 small squares, and that is equal to 6 units of length multiplied by units of width. Now you see, if this whole space is occupied by this rectangle, now what is the area of this rectangle? Same area, the 18 square units, because area is equal to 6 units multiplied by 3 units. So these 6 units is the length of the one side of the rectangle, and 3 units is the length of adjacent side of the rectangle, and they are perpendicular to each other. So what we learned, The area of a rectangle is equal to side multiplied by side only because these sides are perpendicular to each other. The units of length are millimeter, centimeter, meter, decameter, hectometer, kilometer, etc. in metric unit. The original unit is the meter and all other units are the derived units. If the length is more, then we use hectometer, kilometer, etc. And if the length is small, then we may use millimeter, centimeter, and so on. Now, unit of area is square unit. That means this unit may be millimeter or centimeter or meter, and it depends. If we measure in millimeter, then the unit of area will be square millimeter, square meter, or millimeter square, or centimeter square. So if this one unit is say centimeter and this is also centimeter, then the area of the small square will be 1 square centimeter or centimeter square. So area of this whole rectangle is equal to 18, 6 multiplied by 3 square centimeter. So with this understanding, let us discuss the area of a parallelogram. Area of a parallelogram is not equal to side multiplied by side because the adjacent sides are not perpendicular to each other. To understand this, let us cut this parallelogram in this position so that one of the vertical sides become perpendicular to the base side and we get an angle of 90 degree, and we get this angle is equal to 90 degree. Now this side and this sides are perpendicular to each other. Now you take the left part to the right side and join them to form a rectangle. So this is the left part of the original parallelogram, and now let us join this to the parallelogram, and what we get a rectangle. So in this process, the total space occupied is not changed, it remains same. The area occupied by this rectangle is equal to the area occupied by this parallelogram. And for rectangle, we know the area is equal to b into h, where b is one side and h is the adjacent sides, and this adjacent side is also the perpendicular distance. Now this base multiplied by height or base multiplied by the side, that is the area of the parallelogram also. So this is also equal to b into h. But b is length of one of the sides of the parallelogram, and h is not adjacent side of the parallelogram, but this h is called the height or altitude of the parallelogram, and that altitude is measured from the side opposite side of the base, and this become b into h. So this is the concept of area of a parallelogram. That is why the area of a parallelogram is not equal to length of this side multiplied by the adjacent side, but it is true for rectangle only, because in rectangle adjacent sides are perpendicular to each other. Now area of a right angled triangle. So this is a rectangle. The diagonals of a rectangle bisect the rectangle. So we get two congruent triangles. These two triangles are congruent, therefore their areas are also equal. And what is the area of the rectangle? That is equal to base into h. H is the altitude, or this altitude is also the length of the adjacent sides of the rectangle. So definitely the area of one triangle is half the area of the rectangle. Now what is the area of this triangle? Now you see this triangle is a right angled triangle, and area of this right angled triangle is half into BH, and this H is called the altitude of the triangle to the base from the apex, and this is already a 90 degree, so we need not construct an altitude separately for a right angled triangle. Now, what about the acute and obtuse angled triangle? And if we draw a diagonal like this, we get two acute angled triangles, and both these triangles are congruent, and the triangles are acute angled triangle. And what is the area of the parallelogram? That is same base multiplied by h, and this h is the altitude, not the length of the adjacent side. If we draw a perpendicular from this apex, and here we get 90°, then this is also called the altitude h, and this is equal to this h itself. Now, if we take the triangle separately, then we can draw a perpendicular from the apex to the base, and this is equal to 90°, and this is called the base of the triangle. So area of this triangle is also b into h, and only the difference is how we get this altitude. For this, we have to construct a perpendicular from the apex to the base of the triangle. In this case, the diagonal of the parallelogram produce two obtuse angle triangle, because this angle is more than 90°. So we get two obtuse angle triangle, but the triangles are congruent. The area of the parallelogram remains same, b into h, and if we take the triangle separately, then what we have to do, we have to construct a perpendicular to the extended base, and this is equal to 90°, and here this is the altitude of the triangle, and this remain the base. So area of the triangle is the same, half into bh. The only thing is how we get this h. In this case, we have to construct a perpendicular from the apex to the extended base, or base extended. So this is how we have to calculate the area of a triangle based on whether it is a right angled triangle, an acute angled triangle, or an obtuse angled triangle. Area of a triangle, if one side and the corresponding height are given, this is the thing we have learned so far. So if a triangle ABC has a base of AB, then its altitude or corresponding height is CP, and therefore the area is equal to half into base is AB multiplied by CP, the altitude or height of the corresponding base. Now if the base of the triangle is BC, then the corresponding height is AP, and this h is the altitude. So area is equal to half into base side, that is BC, multiplied by the altitude is AP. And if the base of the triangle is CA, then BP is the corresponding height of the triangle, and the area will be equal to half into base is CA multiplied by BP. Now area of a triangle, if sides are given, this is a very interesting formula for finding out the area of a triangle. In this case, all the sides are given. Suppose A, B and C are the measure of the length of the sides of a triangle, then what is the perimeter? We have learned that perimeter is the sum of the length of the sides of a triangle, and perimeter is represented by P, and P is equal to A plus B plus C, that is sum of the length of the sides of the triangle. Now the half the perimeter is called the semi-perimeter of the triangle. So if we represent semi-perimeter by S, then S is equal to P divided by 2, and that is equal to half of A plus B plus C. The interesting formula for finding the area of a triangle with given sides A, B and C is equal to root over s multiplied by s minus a multiplied by s minus b multiplied by s minus c. And this formula is also called the Heron's formula or Hero's formula for finding the area of a triangle when the sides are given. And there are many proofs of this formula, but at this level, at this stage, you need not know the proofs of this formula, but simply you have to use this formula. That means you put the values and get the result. That means get the area of the triangle. Now the area of a trapezium. A trapezium is a quadrilateral with one pair of opposite sides parallel to each other. Here AB is parallel to DC and DA and CB are non-parallel sides of the trapezium. Suppose the length of the side AB is small a and side DC is small b. Now how we can calculate the area of this trapezium? We can simplify it by dividing this trapezium into three different shapes. Say if we draw a perpendicular line from point D to the side AB, then we get one triangle here. And again, if we draw another perpendicular line from point C, we get another triangle in the right side. And at the middle, we get one rectangle. And the sides are like this. AE is equal to C, small c, FB equal to small d, and this EF is equal to B. So this B is equal to D, this B. This whole length A is equal to C plus B plus D. Now come to this triangle AED. The area of this triangle is equal to half into base. Base is AE and A is equal to small c, this one, and the altitude is h. This is the area of this triangle, and area of this triangle is half of the base. The base is FB, that is equal to small d, multiplied by altitude of the triangle, and that is equal to h itself. And area of this rectangle is definitely base into altitude or base into the adjacent sides. So this is how we have calculated the individual areas of the whole trapezium. Now what is the area of the whole trapezium? That is equal to half of CH, that means the first triangle, plus half of the right side triangle, that is DH, the area of the rectangle, that is equal to BH. Now you see we can take half of H common from this, and then there will be there will be C plus D plus B. It should be twice B, then only this 2 and 2 will get cancelled, it will be BH. Now we can rearrange this like this, half of H multiplied by C plus D plus this twice B, you can write B plus B. So this is equal to C plus D plus B. This is equal to C plus B plus D, and that is equal to A. So we get half of H multiplied by A plus B. Now what is A plus B? A plus B is equal to sum of the parallel sides of the trapezium, or we can say this is half of A plus B multiplied by H. H is the altitude of the trapezium and A plus B is the sum of the parallel sides of the trapezium. Okay. The next video will be on solution of the exercises from chapter 20. If you find this video useful, please like it, and I really appreciate if you subscribe to the channel. So thank you once again.